Yes, there's a few comments I could add to the science and religion from before. First, a few missteps, which you probably got. I think I should have said one place. I should have said a down quark instead of a neutron, and an up quark instead of a proton. And then once, when I was describing Newton's law of gravity, I left out a square between for the distances divided by the square of the distance between them. I left that out once. And let's see. And once when I was describing the difference between Einstein's theory of gravity and Newton's, I interchanged. I should have been saying Einstein when I once said Newton. But I think from context you probably gathered that I made a mistake. Now the other thing is that, excuse me, I could have said that when you come to the difference between science and religion, and that science really would have a hard time explaining the near-death experiences and the right brain doing the same thing in your mind. Well, and science, if it has a theory or a postulate, it should take it back to the lab to test it out or create it. So you can ask them, have you been able to create a piece of my mind back in the lab? And of course, they would have to say no. The other thing that I didn't explain is that how did Hubble know that the stars were going away from the Earth, and hence the universe was expanding? Well, as I mentioned, light can be both a wave and a particle. And to see it's a wave, just look through your two fingers with one eye, and you'll see some light lines in between them, just as indicating it's a wave. There's interference of the light waves, just the same as when you throw two rocks into a pool, you get interference of the waves there. Well, Newton, back in the 1600s, he said passing light through a prism, he saw that there are different colors of the rainbow, going from red up to indigo being dark purple, and that each color had a different frequency. So the red, it had also a different wavelength. The red has a wavelength which is larger or longer than the wavelength of indigo. That's the distance between the crests of the two waves. So if the wavelength is longer, that means it goes up and down slower within a particular distance. So the frequency is less. Whereas indigo, it goes up and down more frequently, and therefore the frequency in indigo is greater frequency. And sound is also propagated by waves. So for instance, when you see a train coming, or hear a train coming towards you, the train is squashing the waves together. Therefore the wavelength is less and the frequency is more. And as the train goes by, it pulls apart the waves. So the wavelength is larger and the frequency is lower. So you hear the train going from a high pitch to a lower pitch as it goes by you. And the sound drops. Well, the same for light then, because it's propagated by waves. So when light is going away from you, it comes from the higher frequency, i.e. the indigo, and goes towards the red, or the lower frequency. So you can see the star light going from indigo to red. It's called a redshift. And using a special piece of equipment called a spectrometer, you can see that. And that's how we knew the stars were going away from the Earth, and the Earth and the universe was expanding. So I thought I'd just add those couple things then. Bye for now.